radical equations. The goal is to solve radical equations. A radical equation, surprisingly enough, has a radical in it. So in part A, we have an equation with a single radical, the square root of 3x plus 1. Outside the radical, we have a plus 2, and then that thing equals 7. So there's a definite kind of recipe for solving these. I don't always give you a step-by-step recipe because I want you to think about things. But in this case, it's nice to have it. So when you have a single radical, the first thing you're going to want to do is isolate the radical. So on the left side, you have the radical plus 2, right? So how could you get rid of that plus 2? Subtract 2 from both sides. And I'll write that down in a second, but the first step usually is going to be to isolate the radical. So that leaves us with the square root of 3x plus 1 equals 5. All right. The 3x plus 1 is stuck inside the radical symbol, right? What reverses the radical, the square root? What reverses it? Think in terms of reversibility principle. What could we do to both sides to get rid of that radical? Square, right? Squaring a square root gets rid of the square root, doesn't it? And the balance principle says we should be able to do that to both sides. So, all right, let's square both sides of this thing. So reversibility says square to get rid of the radical. The balance principle says you better do it to both sides, right? Okay, so what happens when you square the square root of 3x plus 1? You just get 3x plus 1, and which is the whole point. You want to get the 3x plus 1 out from underneath that radical. On the right side, what do you get? 25, 5 squared? Everybody buy that? And now you've got yourself a little linear equation. Can you finish that off for me? What do you get? 8 is correct. You subtract 1 from both sides, get you 24. Divide both sides by 3, you get 8. Do you think you can check your answers? Any equation, you can always check your answer, and you want to in these ones because you can get, just like with rational equations, you can get extraneous solutions for these things. So I think you can almost do it mentally. If you plug in an 8 where this x is, okay, the square root symbol is a grouping symbol. You do all the operations underneath the square root first. So 3x plus 1 would turn into 3 times 8 plus 1. What would that be? 24 plus 1 is 25. And then you take the square root. What's the square root of 25? 5 plus 2? 7, right? So yeah, 8 checks. It's not an issue. But not all your solutions are going to check, as you'll see. Any questions on that? So if we had to write down steps, or let's call it a recipe. What was that step 1? Okay, so let's use some symbolism here. Isolate the radical, right? That was where we subtracted 2 from both sides, right? Then what do we do? Okay, square. Okay, so this means I'm going to draw a little square. Square both sides. And then what do we do? So this was step 1 right here, step 2. And then step 3, we solved it, right? Whoops, slove. How about I spell it right? Solve, and then what did I do lastly? Kind of mentally. We checked it. Really important to check your answers here because you will get extraneous solutions. Remember, extraneous solutions are solutions that, even though you've done everything correctly, they just don't check. Why would you get extraneous solutions here? Think about it like this. -2 does not equal 2, does it? I can pretty confidently say that. I'm pretty tired, but I'm pretty sure that's true. I'm pretty sure it's true that they're not equal. What happens if I square both sides of that not equal to statement? I get an equal to statement, right? That's why you get extraneous solutions, and you're squaring both sides of it, of of an equation here, right? But you might be introducing solutions that don't work when you square both sides. So negative 2 does not equal 2, but 4 equals 4 when you square both sides. So you've got to be careful and check your answer for extraneous solutions.